Welcome to Introduction to Document-Based NoSQL Databases. After watching this video, you will be able to explain the fundamentals of NoSQL databases, focusing on MongoDB. Describe how MongoDB stores and retrieves data using JSON-like documents. Perform CRUD or create, read, update, delete operations in MongoDB, and explore real-world use cases of MongoDB in modern applications. As applications become more complex, so do their data storage requirements. Traditional relational databases, such as MySQL and PostgreSQL, are powerful, reliable, and well-suited for structured data that demands strong consistency. However, certain use cases, such as managing large-scale distributed data, unstructured or semi-structured information, or real-time analytics, may benefit from a different approach. This is where NoSQL databases come into play, offering alternative data models that prioritize flexibility, scalability, and high-performance querying for specific workloads. NoSQL databases are commonly used in the following situations. The application requires fast and flexible schema changes. Data is semi-structured or unstructured, such as JSON, XML, or time series data. The system needs high availability and horizontal scaling to handle large amounts of traffic. Complex relationships need to be stored efficiently, such as in social networks or recommendation engines. In this video, we'll focus on MongoDB, a document database. MongoDB is a NoSQL document database that stores data in a flexible, schema-less format using JSON like binary JSON or BSON documents. Unlike relational databases that use tables and rows, MongoDB organizes data using collections and documents, making it highly scalable and suitable for large-scale applications. Real-world use cases of MongoDB include content management systems that store user-generated content dynamically, e-commerce platforms that manage product catalogs with varying attributes, and real-time analytics that store logs and events from IoT devices. A collection in MongoDB is similar to a table in a relational database. However, unlike tables, collections do not enforce a strict schema, meaning each document in a collection can have different fields. Collections store data as binary JSON documents, allowing embedded or nested data structures. They are automatically created when a document is inserted if they don't exist already. The following is a document in a collection called products. Each product can have different fields, making the database highly adaptable. Developers can add fields to this document on an ad hoc basis, as there is no strict schema to restrict that. MongoDB does not use SQL like relational databases. Instead, it provides a JavaScript-based query language and scripting environment that allows users to interact with a database in a flexible and intuitive way. These scripts are run in the MongoDB shell, Mongosh, which provides a command-line interface for querying and managing MongoDB databases. Since Mongosh uses JavaScript, developers familiar with JavaScript will find it easy to use. JavaScript commands for MongoDB can be run in three ways. MongoDB shell, Mongosh, runs commands interactively from the command line. MongoDB Compass is a GUI-based client where you can write and run queries. And MongoDB drivers integrate MongoDB queries into applications using Java, Python, and Node.js. Using JavaScript in Mongosh is a powerful and intuitive way to interact with MongoDB. Whether you're querying data, inserting records, updating fields, or automating database tasks, JavaScript in the MongoDB shell provides an easy-to-use interface for managing NoSQL data. Before we discuss the CRUD operations, let's see the basic structure of a MongoDB query. The basic structure of a MongoDB query is db.collection.method and query, update, options in parentheses. DB refers to the current database. Collection is the collection being queried. Method is the operation to perform, for example, insert one, find, update one, delete one, and so on. Query specifies which documents to target. Update defines changes for update operations. Options refer to additional settings such as sorting or limiting results. Now that you understand the basic structure, let's understand each of the create, retrieve, update, and delete queries. This code adds a new document or record to the products collection by using the insert one method on the products collection. Here, products is a collection that holds product documents. If products does not already exist, MongoDB automatically creates it when the first document is inserted. Each document in the collection represents an individual product, with fields such as product ID, name, price, and so on. Now, let's see how to read data from a collection. This code retrieves all the documents from the products collection using the find method. Next, this find one retrieves only one document representing a specific product with the specified product ID. The find one method returns the first matching document. Next, let's update data in the collection. This code modifies an existing document in the products collection using the update one method. The first parameter, product ID, specifies which document to update. The second parameter, $set, updates the stock field to 75. The $set operator ensures that only the specified field is modified without affecting the rest of the document. Finally, let's find out how to delete data from a collection. Let's say you want to delete one product by product ID. Delete one deletes only one record where product ID is equal to A123. To delete all the products in a category, use the delete many method. In this video, you learned that NoSQL databases are required for managing large-scale distributed data, dealing with unstructured or semi-structured information, and for real-time analytics. MongoDB is a flexible NoSQL document database that stores data in JSON-like documents and organizes them in collections. MongoDB is widely used for content management, e-commerce platforms, and real-time analytics. MongoDB provides a JavaScript-based query language and scripting environment run in the MongoDB shell, Mongosh. CRUD operations in MongoDB allow efficient data manipulation,